Hi guys, welcome to the channel Code Streak Daily. So let's solve the today's Geeks for Geeks problem of the day. So today 28th September and we have the problem minimal cost and it's a medium level problem. It's a medium level difficulty and there are like 58k submissions already. So let's see what the problem looks like. So here we have the problem description. Let me read out the question. There is an array ARR of heights of stone and Geek is standing at the first stone and can jump to one of the following stone I plus 1, I plus 2, so on till I plus k stones, right? Where k is the maximum number of steps that can be jumped and cost will be, here we are taking the positive thing only, hi minus hj is incurred, where j is the stone to land on. So we need to find the minimum possible total cost incurred before the Geek reaches to the last stone. Okay, let's understand that there are a number of stones and Geek is standing on the starting stone. So we need to find the total number of cost or steps that are required to Geek to reach the last stone. Let's see an example. Here we have two inputs. One is k equals 3 and the other is array. We have 10, 30, 40, 50 and 20. So we have the explanation. Geek will follow the path 1, 2 and 5. So the total cost would be 10 minus 30 plus 30 minus 20 equals 30, which is minimum. Okay, now let's see how Geeks follow the second thing. K equals 1, 10, 20 and 10. So here the output is 20. Let's see Geek follow the path 1, 2 and 3. The total cost would be 10 minus 20 plus 20 minus 10 equals 20. Okay, let's see how we will find an approach to solve this problem. The constraints, like the time complexity should be order of n times k, that's the length of the array times k, and the auxiliary space needed is the order of n, and there are certain constraints here. 1 less than equals array size less than equals 10 power 4, and 1 less than equals k less than equals 100, and 1 less than equals array of I less than equals 10 power 4. Okay, now let's see how we could be able to solve this problem. Let's use a dynamic programming approach to store the minimum cost to reach each stone, and we have to, for each stone, Geek can jump from any of the previous k, that is k stones. So we can check all the possible jumps from stone I minus k. So for I minus k to stone I minus 1, the cost to jump from each stone, that is from I to j, so we are taking the absolute difference between their heights, right? That is hi minus hj. So here we need to initialize a dynamic programming array. Like let's say I would take an array called dp, dynamic programming array, where dp of I, that is the I value holds the minimum cost to reach each stone I. Okay, so let's see what steps we can use to solve this. So first of all, we need to use a dynamic programming array, that is dp array, with size equals to the number of stones. Okay, that is length of the array. Then we are going to set the dp of 0 is equals to 0. Like I say, dp of 0 is equals to 0, because no cost is incurred to stay on the first stone. Okay, now we have to see for each stone from I equals 1 to n, we have to calculate the minimum cost to reach from any of the previous k stones. Okay, see, now we have to see the value dp of I will be the minimum of dp of j plus array of I minus array of j. Okay, where j will be the range, that is I minus k and I minus 1, that is the previous k stones. Then we are going to return the dp n minus 1 as the answer, which is the minimum cost to reach the last stone. Okay, now let's see how we will be able to do this thing in the coding part. As I said that we need the length of the array. First of all, let's take n equals length of the array. Then as I said that I'm going to initialize a dynamic programming array, then I'm initializing it and I'm taking it as a float. Okay, then the initialization that I have done, the size of the dynamic programming array should be equals the size of the array. Okay, so I'm taking times n dp. Now I'm going to initialize the first value equals to 0 because on the starting stone where Geek is currently standing, the cost incurred to stand on the first stone will be 0. So we'll have initialized the dp of 0 equals to 0. Now we have to compute or calculate the minimum cost to reach each stone. So let's take a for loop for I in range of 1 to n some from second stone to last stone, because here we have initialized the starting stone cost is equals to 0 because the geek is standing on the current starting stone. So we don't need to calculate the costs with on which the geek is currently standing. So we are taking it from 1 to n. Okay. Then we are also taking another for loop for j in range of maximum of, as I said in the explanation here, maximum of I minus k to I. So here we are taking the maximum value from 0 to I minus k, where we can find it from current stone to next stone. So dp of I would be, we need to find the minimal cost path, right? So we are taking the minimum value dp of I as well as dp of j, plus we also need the difference between the hi minus hj, right? So we are taking array of I minus array of j. So this gives us the absolute difference between those. Then we have to get out of the both for loops. Then we are going to return dp of n minus 1. So it stores the minimum cost to reach the last stone. Now let's see if we could able to do this in the first attempt itself. Okay, for the given input our output is 30 and the expected output is also 30. Let's try to submit it. Let's see if we can attempt it in the first, if we can do it in the first attempt. Oh, there are 1115 test cases. Done. So everything seems good, the code is working perfect. We are able to solve all the test cases. Those are 1115 test cases, and we have successfully done it. The accuracy of my code is 100%. So because I have attempted it in the first attempt itself, right? So this is today's problem of the day for Geeks for Geeks. Then the question is minimum cost and the difficulty level is medium. So do check out this code, and if you have any other codes that's more efficient than this code, please comment that code, and I'll definitely check and I'll try to work on it as well, and I'll try to improve my code in the next videos. So if you want further more challenging codes, or if you want further more updates on daily problem solving on both Geeks for Geeks and Lead Code as well, do subscribe. Thank you.